We have made it to the third and final test review for the Trig Identities unit. For number 1, it says prove or verify the following. I'm going to simplify the left-hand side. Oh, couldn't even see that. Hang on one second. All right, that'll make it easier. Okay, so 1 plus cotangent squared is here, which is cosecant squared. And when you have cosecant divided by cosecant squared, the term in the numerator eliminates with one of the terms in the denominator, and 1 over cosecant is sine of x, and that is exactly what we needed. For number 2, it says sine of x plus cosine of x squared, so that means I'm going to multiply that binomial times itself. You can FOIL or box method or distribute, which I will do. So sine times sine is sine squared. Sine times cosine. Cosine times sine, but I'm going to write it in this order. And then cosine times cosine. So then sine squared plus cosine squared is 1. And these are the same. And then 1 plus 2 sine, so this 2 sine x cosine x is sine of 2x. And that is what we needed. All right, in 3, the terms on the left, we have a shared term of sine squared that I can factor out. So then 1 plus tangent squared here is secant squared. And then secant I'm going to rewrite as 1 over cosine squared. And then I'm going to multiply these fractions together. And sine divided by cosine is tangent, but both squared, so tangent squared. That's what we needed. Oh, darn, it was thetas. Sorry, these all should have been thetas, but you get the idea. All right, number 4, solving. I'm going to think of this as a quadratic without cosines. So 2 times 1 is 2. The only way to multiply to 2 is 1 and 2, and thankfully that adds to 3. I'm going to factor it with box method. So I'm going to do 1w and 2w. So these each have to be 1 to multiply to 1. This would have to be a 2w and a w. So we get 2w plus 1. But we didn't start with w's, we started with cosines. Now we can set each factor equal to 0. Isolate the cosine of x. And then I need all my special pictures. So I'm gonna get a fresh piece of paper and draw them so that I can keep referring to it. Okay, so when is adjacent, so cosine is adjacent over hypotenuse. So when is the adjacent 1 with a hypotenuse of 2 is the angle pi over 3. That's going to happen in 2 places, but I want when cosine is negative. So that happens here and here. So 2 pi over 3 and 4 pi over 3. Because this would be 3 pi over 3, which is 1. So a little less than 1, a little more than 1. This angle is saying when is cosine of x -1. So I go to my quadrantal angles. And that happens over here at pi. Okay, number 5. Tangent of x. I'm going to subtract the 1 to the right. So this is saying when does tangent equal 1? So that's opposite over adjacent. That happens with pi over 4 where they are 1 and 1. But I need the quadrants where tangent is negative, which happens here and here. So since we're dealing with 4, pi is 4 over 4, so this would be 3/4 up here. And then this one is almost 2, so that's 7 pi over 4. All right, that's page 1. Page 2, or page 69 in the packet, page 2 of this review. Find sine of 15 using a half angle formula. So something divided by 2 is 15, and that's 30. Now, in the last video, I did not explain very well how you pick between positive or negative with the radical in sine and cosine half angles. So let me do a better job with that. 15 is in the first quadrant, and sine in the first quadrant is positive. So we are going to use the positive square root. I'm going to use this identity. You don't have to write the plus. It's assumed when you don't write it. So now cosine of 30, cosine is root 3 over 2. I need a common denominator in the numerator, so that's 2 minus root 3 all over 2 times a half. This is like 2 over 1 multiplied by the reciprocal. So that gives us 2 minus root 3 over 4, and then the square root of 4 is 2 for the denominator, and 2 minus root 3 is the numerator. Find sine of 2 theta if sine of theta is 3/5 and theta is in the second quadrant. So that's over here. Sine is opposite over adjacent. And Pythagorean theorem would get us 4, but it's negative because we're to the left of the origin. So sine of 2 theta with our identity is 2 sine theta cosine theta. So we are going to fill in fractions for these. 3/5, negative 4/5. I'm going to put the 2 over 1 so I line up my numerators and multiply the denominators. Okay, 8 is similar. Tangent is negative. That happens here and here. But this cosine is positive, which happens to be in this fourth quadrant. So cosine is adjacent over hypotenuse. So now I need to figure out the vertical piece. So this is going to be the square root of 33, but it's down, so negative root 33. And it says find cosine of 2 theta. Well, we have 3 choices for that. I'm going to use the first one. I don't know, that's a personal preference. If you wanted to use one of the other ones, you absolutely could. So I'm going to use a fraction squared minus a fraction squared. So from this picture, cosine is 4/7, sine is negative root 33/7. So 4 squared, 7 squared, negative root 33 squared. So we're going to get negative. And this didn't say no calculator, so if you want for your arithmetic, negative 17. And we can check and see if it reduces, and it does not. All right, another half angle. for cosine. So how do we decide positive or negative? What's going to happen is pi over 8 is in the first quadrant, because that's 1/8, and up here is 1/2, and 1/8 is smaller. And in the first quadrant, cosine is positive, so I'm going to use the positive radical. But I have to figure out what angle that is. So what divided by 2 would give me pi over 8? Or what times 1/2 would give me pi over 8 is pi over 4. So this is asking, and it's 1 plus cosine of pi over 4 all over 2. So then, all right, cosine of pi over 4. We've got cosine adjacent over hypotenuse. I don't like that square root in the denominator, so I'm going to use the root 2 over 2 radical that we know. So when I add those with a common denominator, times 1/2, which gives us the square root of 4 in the denominator, which is 2. Oh man, 10. All right. Do it like this. Cotangent of alpha is 12/5 when we're in the first quadrant. Cotangent, oh, that's an A. You don't have to say alpha. Totangent is the reciprocal of tangent, so that is adjacent over opposite. With Pythagorean theorem, is 13 for the hypotenuse. And now let's figure out everything. A is sine of 2A. Using the identity, 2 sine cosine. So sine is 5/13, cosine is 12/13. So this is 10 times 12 and 13 times 13. B, cosine of 2A. I'm going to use the cosine squared minus sine squared identity. So that's a fraction squared minus a fraction squared. Cosine 12/13, sine 5/13. And then when we simplify, we already have a common denominator. That is 119 in the numerator. Okay, so I'm going to use that same picture for C and D. So alpha, or A over 2 for sine. Now, we're in the first quadrant, and in the first quadrant, sine is positive, so I'm going to use the positive square root. It's 1 minus cosine, which is 12/13, all over 2. So I'm going to make 1 into 13/13. 13 minus 12 is 1 times 1/2, so we get the square root of 1 over 26. Well, the square root of 1 is 1, so you could write it like this. And then if we wanted to eliminate the square root in the denominator, it's root 26 over 26. Cosine of A divided by 2, in the first quadrant, positive radical, 1 plus cosine. I'm just using this identity now versus that one. So 1 is 13 divided by 13. So now this is 25/13 times 1/2. Ooh, and the square root of 25 is 5. And then 13 times 2 is 26. Eliminate the square root in the denominator. It's 5 root 26 over 26. Okay, moving right along. Number 11. Sum and difference formulas. Oh, I probably have enough room there. So 105. Because of the ends in 5, I'm going to use 45. So let's see what angle we're left with. 60. That's good. That's one of my special angles. Cosine sum is this identity. So that's cosine, change to negative, sine. Now we need my special pictures. I got a lot of papers here. Where to go? Here we go. Cosine of 45, which is pi over 4, is root 2 over 2. Cosine of 60 is 1/2. Sine of 45, and then sine of 60 is root 3 over 2. And when we multiply, root 2 over 4 minus root 6 over 4, root 2 minus root 6, all divided by 4. Okay, ooh, 195. So I'm going to use 45 as one of the angles. The remainder is 150. And the sine identity, sine, cosine, same sign, plus, plus. So we go sine, cosine, same, cosine, sine. So now cosine of 150 and sine of 150. That's a reference angle of 30 because it's 150 is 30 less than 180. Puts us in the second quadrant. Cosine is negative there, sine is positive. Cosine of 30 is root 3 over 2, and sine is 1/2. Oh, you can't see that. Cosine of 30 is root 3 over 2, and sine is 1/2. So this gives me negative root 6 over 4 plus root 2 over 4. Oh, it's the same answer. Does not matter the order you write your numerator in. Okay, now pi over 12. Pi over 12, I want to know, okay, and to get 1. So if I do 4 pi over 12 minus 3 pi over 12, that gets me 1/12. And this reduces to pi over 3 minus pi over 4, which is great because there are some of our special angles. So let's find the tangent identity. Here it is. Minus in the identity is a minus in the numerator with a plus in the denominator. So tangent of pi over 3 minus tangent of pi over 4, all divided by 1 plus tangent of pi over 3 times tangent of pi over 4. Okay, so tangent of pi over 3 is opposite over adjacent. Root 3. This is great. Tangent of pi over 4 is 1. So then this is 1 plus root 3. And I'm going to leave that as my answer. We're good. Simplify the following and evaluate. So using the identities for number 12a, this simplifies to, sine of 2 angle, which is sine of 30, which if you go to your special triangles is 1/2. Now cosine squared minus sine squared I know is the cosine of 2 angle, which is cosine of pi over 4. We get root 2 over 2. Cosine negative. Cosine negative is a cosine sum. So this is cosine of 20 plus 40, which is cosine of 60 degrees. So make sure you can see the pictures. So here's 60, cosine is 1/2. And then D, these switch, so it's the sine same, so that's 100 plus 20. You can always consult your formula sheet here. Plus in the top of the symbols is that plus in the top of the symbols. So sine of 120, well, that's a reference angle of 60. Sine of 60 is root 3 over 2. And 120 is in the second quadrant, so positive. Okay, last page. 0 and 2 pi. So that is like this because of that inclusive word. So because this is 2x, really, I'm going to double where I'm looking. So 2x is going to give me, and I need 2 answers for negative. So cosine is negative in the second and third quadrant. This is adjacent over hypotenuse. So I come here to my paper. What angle is adjacent to the root 3 is pi over 6. But in the second quadrant, that is 5 pi over 6. And in the top quadrant, in the third quadrant, that is 7 pi over 6. So now, we have to go to 4 pi. So I'm going to take 5/6 and add a rotation. Oops, math. That's 17 pi over 6. And I'm going to take 7/6 and add a rotation. 19 pi over 6. So if we went again, we would be past 4 pi. You can see how this is 3.1. So it's almost 4. So we're not going to go again. We're not going to add again. But now 2x equals all of these. So really, to isolate the x, I'm going to multiply everything by a half. So our final answers are 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12. Find all solutions for sine of x over 2 equals negative a half. So whatever angle x over 2 is going to be, I want to know when does that give me opposite over hypotenuse of negative a half. And sine is negative in the bottom 2 quadrants. So opposite of 1 is this pi over 6. But as a reference angle, so then in this quadrant, it's going to be 7 pi over 6, and this quadrant, 11 pi over 6. Okay, this says all solutions. It did not change, it did not give us any restrictions for the angle. So what we have to do is consider all angles. So each of these angles, we can add a rotation as many times as we want. So I'm going to say that's times k. You could pick any variable. K is usually used like constant k, not c. Because 7 pi over 6, which is here, well, I can also go all the way around and back, and that would give me the same answer. But I could go around twice and make that 2 or 3 or 4 or 5, 6. I can go around infinite times. So then I'm just going to solve each of these for x. So we'll multiply both sides by 2. So x is, this will give me 14 pi over 6 plus 4 pi k, or 22 pi over 6 plus 4 pi k. But then the 14/6 reduces to 7 pi over 3 plus 4 pi k, or this also reduces to 11 pi over 3 plus 4 pi k. So these are the 2 answers for 14 and 15. The last but not least, to verify, sine is complementary to cosine. And then tangent is sine divided by cosine. And these simplify, and we get the answer we needed.